So I'm Dave. I work at ThinkBinder. We are an education technology startup. We're trying to right now create a collaborative real-time collaboration tools for people so that they can communicate and study and work and tutor each other online in a very interactive, seamless way. What I'm going to do today is we've actually been developing something very recently over the last couple of weeks, which is an interactive whiteboard application. It's basically, if you're familiar with Convideos, you notice he uses these interactive whiteboard type applications to kind of diagram his lessons. And we're trying to build something similar to that, but that allows real-time collaboration so that two people can be looking at the same whiteboard, and you can see, as one person draws, the other person can see the same thing. You can save these files and load them. And so it's still very much an alpha, but I'll show you what we have now, and then you can kind of use that as a launchpad to talk about how Node.js was perfect for this, how it made developing something like this significantly easier than it would have been using traditional PHP stacks and stuff like that. And then I'll take any questions you guys have. So if we look, quick overview, most of the site is based on a PHP library or a PHP stack that serves all the basic content. But once all the stuff is loaded into the browser, it calls a library that's based on a Node server, and then that handles anything that's real-time interactive. Anytime data needs to be pushed to the browser, we try to funnel all of that stuff through Node.js. So at the very basic level, you can kind of see how there's this a buddy list here where you can see who's online and who's not. And very simply, you can see things like there's a chat interface that allows you to chat, but not for interesting stuff. And by the way, we're using something called Paper.js. I don't know if you guys are familiar with it, but it's a vector processing library for JavaScript that makes generating these whiteboard applications very simple. So if I show you here, you should be able to see what happens over here on the left, but as I draw over here on the right, everything that's getting written here is getting pushed to the server, and then consequently it's getting pushed out to everybody else who is in the same page. It keeps a persistent history of everything in a Redis database, so that every time you reload the page, you can loop through the entire history and it'll kind of redraw everything. And so one of the cool things about this is that the actual client-side library, probably a couple thousand lines of code to get this just a pure basic whiteboard functionality. The overhead on that to add the real-time interactive stuff using Node.js and Socket.io was something like 200 lines of code, which is pretty crazy. You would think that for something like this, the concurrency would be the thing where you really get bit, and that becomes really tough to do. But if you using Node.js and Socket.io, which is a WebSockets library, it makes some of these things trivially simple. So kind of just to give you an idea here, looking at the code, basically these are the relevant parts. When a client connects to socket code, you just say socket join, and then the group has some kind of unique identifier. And then every time somebody does something on the client side and gets pushed, all it does is it takes that message that got pushed from the client and just rebroadcasts that server. And that's pretty much it. And there's a lot of other stuff going on to keep things persistent in the Redis database and stuff like that. But for the most part, if you keep your protocol pretty simple, it can be as simple as 3 lines of extra code on the JavaScript server to handle the concurrency. And similarly, on the client side, the actual code to do this is really, other than creating the data structure, which takes a lot, all you have to do is say socket emit, which means push it to the server, and it just sends a message, and then you just have the server refunnel it back. So basically, we've been able to extract the whole entire concurrency problem and the real-time interactive stuff, and just really, use the server as a very simple message transfer system, and then everything else just kind of falls in place and is very simple to do. So right now we're trying to, some of the ideas we have is we'd like to now, because all the history of these is completely held in a persistent Redis database, and you can kind of see in Firefox it'll kind of draw things in progression. We'd like to do something where you could kind of, are you guys familiar with Stipe at all? So Stipe is this thing where it's like a real-time text editing application. And what you can do is you can do a playback, where you can play back how that document was created. So similarly, we're going to try to implement something where you can go through and play back and kind of undo actions and just kind of almost in a way create a movie out of what you're drawing and diagramming. And because it's not actually a movie, because it's all based on this very simple drawing protocol, you could create a 10-minute video or a 10-minute, drawing video, and you could probably, if you don't actually transmit it to a video, you just keep it as basic JSON messages. It probably only takes like 30 kilobytes or something, which is pretty incredible, and makes you don't have to worry about the tremendous bandwidth issues you get when you're dealing with things like streaming video and stuff. So yeah, this is very alpha. We still have a lot of features to go, but I think it's kind of a proof of concept of how you can use Node.js to very simply add this interactive element to your websites and your web applications.
Are you using Canvas or SVG?
It's Canvas. It's all HTML Canvas. Paper.js is a Canvas-based library that lets you do vector processing. So as I draw, you'll see like it has some cool stuff where it'll kind of like smooth lines out and things like that. And it does a really good job of, instead of having to deal with the Canvas elements at a pixel level, you can kind of deal with them as objects, which makes things like this a lot easier to do.
I have a question about your business model. When I saw your presentation, I thought it reminded me of Google Docs collaboration. How do you differentiate yourself as opposed to someone just using Google Docs to tutor somebody?
Google Docs, I don't think do you have a drawing application? Or I don't know. I'm not really.
This is already something like that.
Yeah.
That allows collaboration.
Right.
How do you differentiate yourself? I suppose using like a office collaboration.
Yeah. So one of the things that I think, so a lot of functionality in Google Docs, we're replicating a lot of that functionality, but I think, and from a pure technological standpoint, there isn't that much value in consolidating these or repackaging them. But I think for education, I think there is a value in, say, one of the ways that we're kind of targeting this is that if you have a study group or something for a class, for a project or something, you can create a ThinkBinder group, create a private group, which is completely private, and have everything consolidated. And there's kind of, I think there's, so a lot of our features, we kind of have, a news feed, a file system, and a whiteboard, and then we also have video chat over here. And the real strength of this is that it kind of consolidates and kind of cleans things up and makes it and gives the user a much cleaner interface for what they want to do. And you're right, if people are so inclined, they can go to Google Docs and try to go to some document and edit. But what we do here is we kind of have everything very consolidated, where it makes it a little bit more of a seamless integration between all the different things. And for example, we have things like you can upload a picture and then we're working to embed it into a whiteboard application as you're working on it. You can look at pictures simultaneously. So I think you're right. If you look at any pure technology, you can probably find it somewhere else. But I think there's value in consolidating and creating seamless integration between all of them.
I'm Andrew Davis. I work on the HTML5 library for Kaltura. And lately I've been concentrating on getting our test swarm up and running, which we do integration testing to make sure that the library works on every browser. So in the case of, Internet Explorer 8 and 7 and things like that, the library will be operating in a Flash mode. So we have to make sure that the Flash library or that our Flash player has the same callbacks and things like that as the HTML5 version of the library and the HTML5 media element in general. So that when you're writing code, you can write once and it'll run everywhere. And the way we make sure that when we change the library to improve it, that it stays the same everywhere is we run a continuous integration testing system. And we do that with jQuery Test Swarm, which is also written by John Bressig as well for Mozilla. So, okay, integration testing is you test the product, you test the final version of the software, everything combined together, every component of the software integrated together. And you run your commands as you would use it with the application programming interface. And you just run every command possible that the program is supposed to provide the user, which in this case is developers like you. And you run every command and you make sure it works. And for that, we have to run in the browser. All of these browsers. Multiple versions of all of these browsers. So we use TestSwarm. And it's just an Apache application. You load it up on your web server. It's got a database that's its backend. And it works in any browser. It runs many different testing frameworks. We use QUnit, as does jQuery. But it will also even run Selenium tests, unit test JS, JS spec, JS unit, Dojo, and ScrewUnit. It's open source, developed by Mozilla, and it's actively maintained. Currently, you'll notice Firefox versions are jumping rapidly. Like we're up at 8 now, or is it 9 already? 7? I think 8's out. Let's see. So that's something that needs to be changed in TestSwarm. Is right now our TestSwarm does not run on Firefox 8, but that's just a matter of adding another record to the database. So here's what it would look like in a full HTML page. We require the jQuery latest, and we get the QUnit CSS, and then we get the QUnit JavaScript, which is a little bit truncated there. And then we put our test within a jQuery document ready. And so we'll run that. And that runs really fast because it's not very complicated. It's just saying that the value is equal to hello. And you see the way it runs is the browser goes to a new page that has the QUnit test in it, and then the test automatically runs. So what TestSwarm facilitates is it sets up a queue so that multiple browsers can access this queue. And each of them will run all of these tests, and it will make sure that they run the same everywhere.
So Andre, this result is a consolidation of all browsers? If
No,
one browser fails,
this is just this browser. This is what running a QUnit test outside of TestSwarm looks like.
Yeah, so to make it clear, you need to run this on every browser.
So to easily run a bunch of different browsers on a bunch of different operating systems, we have to virtualize all those operating systems, which means that we have one computer and we run Windows on it, we run Linux on it, we run several different versions of Windows on it so that we can test in Internet Explorer 7, 8, and 9. And Firefox, we run on Linux. We can run multiple versions of Firefox on the same operating system there. And so right now we're using VMware for this.
So you do this manually?
No, we have it all automated. So VMware, it boots up, and then it boots up a bunch of different operating systems. And as soon as the operating system boots up, it opens up Internet Explorer or Firefox or Safari, whatever we need that operating system to run. It will boot that software up and access the TestSwarm at a specific URL. And then it just runs tests. And when it's done with one test, it goes on to the next one.
So Selenium isn't good enough. You have to actually, you find that Selenium was good enough, you have to actually run the browser.
When we began developing our testing system, Selenium was going on through its transition from version 1.0 to 2.0. And Selenium, the way it works is you tell your Selenium server to command a browser to do things. But TestSwarm, all you have to do is the browser just goes to a URL, and then the browser will keep running tests as long as it can. So right now we have our machine set up to reboot once an hour and start testing again. And so it just works its way through the queue, and there's less room for error there. Or actually, there's more room for error, if you can look at it that way. Because if we run our test wrong, and they send out an alert and halt the browser in some way, the computer's just going to start up and start testing a VM. And it's more fault tolerant to use test swarm than Selenium. So we're using VMware right now. It would be better to switch to OpenStack or Eucalyptus, something like that. But VMware is just